All right, so today we're going to start looking at factoring. So factoring is honestly one of the most important things that you need to learn how to do this year if you don't already know how to do it. There are several steps to factoring and several different methods. It all depends on what you were given to start with, your original equation. So remember, factoring is kind of like reverse foiling or reverse distributing. Step one, every time you're asked to factor, is always going to be to look for a greatest common factor. Okay, is there something that you can divide out of all of your terms to reduce it more before you factor any further? Also, if your first term or your leading coefficient is ever negative, then you should actually factor out a -1 or a negative to before you try to factor it any further. Okay, so starting with question number 1, is there a greatest common factor? Is there something that can divide into both 3x squared and 6x? Okay, so your numbers are pretty easy. You're probably pretty good at those. I know that I can divide both of those by 3. Okay, be sure you check your variables too. Both terms have at least one x. So I can go ahead and actually factor a 3x out of both of those. When I do that, what I have left is actually going to be what you get if you divide these by what you factored out. So if I divide 3x squared by 3x, all I'm left with is an x, plus 6x divided by 3x is just a 2, and this has been completely factored. Okay. Same thing on question number 2. Step 1, always, is there a greatest common factor? Is there a number that divides into both 25 and 30? That's going to be 5. Can I factor some y's out, some of those variables? Well, both terms have at least 2 y's. That means I can take a y squared out. When I take that 5y squared out, again, if you want to know what's left inside, you can actually divide it. I don't usually write that down, but sometimes I do. It just helps me stay a little more organized and remember to do everything. 25 divided by 5 is 5. Y cubed divided by y squared is just 1y left, minus 6. And this is my solution. Question number 3, greatest common factor. All of these terms are going to be divisible by 2. And then looking at my variables, this one doesn't have an x term, so I can't factor an x out. To be able to pull an x out in front, you have to be able to take it out of all 3 terms. But what I do have is this leading negative right there. It says right here, if first term is negative, you need to factor that negative out. We want our leading coefficient to be positive. So I'm actually going to factor out a -2. And then again, if I divide all those by -2, that's going to be a positive 3x cubed plus 2x squared minus 4. This has now been completely factored. Looking at question number 4, do I have a greatest common factor? Is there a number that divides into 6, 15, and 11? Nothing besides 1. Can I factor a variable out? No, because the last term doesn't have one. The only thing I can do to this question is factor out the -1. Again, we don't want our leading coefficient to be negative. When you start factoring further, you're going to understand a little bit more why you have to do that. Okay? So that's our first step. That's our first step every time you're having to factor. After that, it depends on how many terms you have left on which method you can use. So our first special method happens when you just have 2 terms. You can check to see if those 2 terms are a difference of 2 squares. Okay, is it something squared minus something squared? In that case, I can factor it like this. Okay, so looking here at question number 5, x squared minus 9. Well, x squared is the same thing as x squared minus 3 squared. So this is a difference of 2 squares. I can factor it into just x plus 3 times x minus 3. Now I'm going to be honest with you. Most of the time I do not write this down, but I'm just writing it down right now to kind of help you out a little bit. Looking at question number 6, this first term right here is the same thing as 2x squared minus y squared. So again, I have a difference of 2 squares. I can factor this into 2x plus y and 2x minus y. Looking at question number 7, kind of same thing. Do I have perfect squares? Yes, this is just 5x squared minus 7y squared. So again, I can factor this into just 5x plus 7y and 5x minus 7y. I will tell you that technically the order of these signs don't matter. I could have written 5x minus 7y and 5x plus 7y. It means the same thing. Okay. Checking out question number 8. Is this a difference of two squares? Can I write this as something squared minus something squared? I cannot using like rational numbers. I can't. I could write like the square root of 5 and stuff like that, but that looks terrible. Don't do that. This question is actually already factored as much as it can. It's what we call non-factorable. Non-factorable. I can't factor that any further. Question number 9 is one that tricks people every single time. X squared plus 9. Well, that is x squared plus 3 squared. But the problem here is the plus sign. This is not a difference of two squares. Difference means subtract. So I actually cannot factor this one any further. It is also non-factorable. Last example here, 169, that's 13x plus 10 and 13x minus 10. Honestly, not a bad idea for you to try to memorize your perfect squares, at least to like what 15 squared is. Okay, that's really going to help you out as we continue on throughout this class. Okay, looking at our next method. Next method happens when you have 3 terms. Okay, 3 terms. So I have, and to start with here today, we're only going to look at when that leading coefficient, the leading x squared term, is only x squared. It's not like 2x squared or 3x squared. That's going to come with your next video. Okay? So the first thing I like to do with this is I have this little sign chart that I like to use to help me out. So I'm going to write it down first. If your first original equation has plus plus in it, so like plus plus, then your two factors are always going to be plus plus. If your first two terms, your first original equation is plus minus, then your two factors are going to be plus minus. If your first equation is a minus plus, then your two factors are going to be minus minus. And if your original is minus minus, then your two factors are going to be minus plus. Okay? I'll explain those to you a little bit more as we go through this problem. So the first thing here, looking at question number 11, is this plus plus. Okay, so remember that when we are factoring, again, we are reverse foiling. So before we actually start factoring, I'm going to FOIL something out here. This is just an example. What if I have like x plus 2 times x plus 3? Okay, so I hope you know how to FOIL. That's first is x squared outside and inside, so that's plus 3x plus 2x last, plus 6. When you reduce this, you get x squared plus 5x plus 6. So looking at this answer compared to your original, let's talk about a few things. Where does the 6 come from in comparison to these two numbers? Well, the 6 is those two numbers multiplied together. The 5 is those two numbers added. Okay, and it depends on what your signs are on how this is going to work out. So the only way this last term is going to be positive is if either, because you're multiplying these two numbers together, if either they're both positive or if they're both negative. That's why on the two ones that end with a plus sign, your signs are going to be the same. Okay, if the last term is positive, then they had to both be the same sign. And whatever sign that is, since this comes from them adding together, it's going to be whatever sign that is. So that's why plus plus equals plus plus, and minus plus equals minus minus. They have to both be negative to be able to add to be a negative, and multiply to be a positive. If the last term is a minus, then that means your two terms had different signs. And honestly, your order here doesn't actually matter, plus, minus, and minus, plus. The order doesn't matter. I like to write it in a specific order because I always factor the biggest number first, but it actually doesn't really matter that much. You just have to be sure that if the middle term is a positive, your bigger number goes with the positive sign, and if the middle term is negative, the bigger number goes with the negative. So let's look at this example number 11. Factoring it. Plus plus tells me that my two factors had to be an x plus and an x plus. Okay. To figure out what those numbers are, I need to know the factors of 36. What multiplies together to be 36? Well, that's 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay? I'm looking for two numbers that multiply to be 36 and add to be 15. So which of those numbers multiplies to be 36 and adds 15? That's 3 and 12. I always write the biggest number first, but like I said, it honestly doesn't matter. And this is my solution. Same thing on question number 12. Minus plus is a minus minus. Again, ends in a positive, tells me the signs have to be the same, and they're going to add to be a negative 9. Looking at my factors, what all multiplies to be 14? That's just 1 and 14 and 2 and 7. Which of those is going to add to be 9? That's 2 and 7. I like to write the biggest number first. Question 13. Again, factoring it. Plus minus. Two ways you can look at this. Option number 1, I like to just remember my signs. Plus minus is going to be plus minus. Option number 2, remember that the negative tells you they have to be different. The positive tells you the biggest number has to be positive. Looking at your factors of 22, there aren't too many of them. It's just 1 and 22 and 2 and 11. Which of those numbers are going to subtract, because they're different signs, to be 9? That's 11 and 2. Biggest number goes first. Question 14, last one here. Again, drawing my two parentheses, minus minus is going to be a minus plus. Again, your signs don't actually matter. You just have to remember the biggest one has to be negative. Multiples of 14, or factors of 14, 1 and 14, 2 and 7. Again, I'm looking for two numbers that subtract, because the signs are different, to be a negative 5, 7 and 2. And this is your solution. Okay. The last step, factoring completely, which is actually what you're doing every single time. Factoring completely means you may have to do multiple steps to have this completely factored. Remember, step 1 is always look for a GCF, a greatest common factor. So looking here at question number 15, do I have a greatest common factor? Yes, I do. All of those are divisible by 3. If I factor the 3 out, I'm left with x squared plus 8x plus 15. But I'm not done, because I can factor what's still inside the parentheses using the method we just learned above. Plus plus is going to be a plus plus. What multiplies to be 15 and adds to be 8? How about 5 and 3? 5 and 3. Common factor needs to hang out in front, and I've now factored this completely. Remember, if you ever want to check this, you can always multiply this stuff back out and distribute the 3 and make sure that it equals this. If you're going to do that, I recommend foiling this first and then distributing 3 through there. Don't try to distribute the 3 first. Looking at question number 16, step 1, greatest common factor. This greatest common factor is going to be a negative 5x. I can divide all those by a 5. I can take out an x. Remember, we want that leading coefficient to be positive. I didn't have a rule up here that was like a minus plus plus or a minus plus minus. So we want that first term to always be positive. When I take out the negative 5x, I'm left with an x squared minus 10x plus 24. Again, I can go further here. Minus plus is a minus minus. What multiplies to be 24 and adds to be 10? Multiplies to be 24 and adds to be 10. Don't tell me 12 and 2. 6 and 4, right? Adds to be 10, doesn't subtract to be 10. Negative 5 hangs out in front, and this is my solution. Looking at question number 17. Step 1, always check for a greatest common factor. Both of these terms are divisible by 5. If I take the 5 out, that's 25x squared minus 16. Again, I can factor this further. These two are perfect squares, and they're subtracted, so they factor into 5x plus 4 and 5x minus 4. Greatest common factor of 5 needs to hang out in front, and that's my solution. Last question. Again, check for a common factor. I can divide both of those by 3. I can take at least 2 x's out of both of them, and I want my leading term to be positive. So I'm going to factor out a negative 3x squared. If I factor out a negative 3x squared, I'm left with just an x plus 4. X plus 4 cannot factor any further, so I am done. I have factored completely.